and eventually, who knows, it will be Datatopia. And Gartner Group already called for article that for future scenario on the role of information technology in society, business, personal life, 2013. The president, CEO of the Alibaba in China, it's Jack Ma, right? Jack Ma announced the beginning of this year, the next few decades will be data-driven society, which means data will determine everything. So I think that may be true. So which means we have a lot of opportunity we can do. Okay, so because of that, you are taking the discourse. I'm teaching the discourse. As I introduced the beginning of the this semester last week, I'm offering the discourse and followed by the NoSQL database that I'm going to introduce a little bit, and also data mining. Some of you guys already took the course, as well as the advanced database course that will be the new concentration on big data and data analytics. Also, if you are interested in something research on the big data, there are a lot. Even the U.S. government, Obama government, they fund a lot of money for the big data. Why? To stimulate the economy. So because of that government funding, there might be a lot of companies who are doing the research or the business regarding to using or regarding to that big data. So there are a lot of opportunity we can do. Okay, so I think the first reading assignment is this one. To understand, I actually skip one part, that is how to store, how to manage the big data. That is our main part in this class. So to understand that one, these two papers are most important paper. So don't forget to submit on time your summary of the paper on Canvas. Okay. So we realize that the big data is important. Then, and as a computer science student and computer scientist or the IT information technology expertise, how can we approach such a big data? First, we should be able to manage, store the data, manage the data, and process the data. That is the most important one, right? In the computer science. So throughout the semester, we will discuss about how to manage, how to store, how to process such a data using. We are going to use the Hadoop system. So we will see what is. Last week I briefly introduced about the Hadoop, but we will see details about the Hadoop system. And also using that Hadoop system, we are going to process, analyze such a data, which is the big data analysis. Okay, then what is the ecosystem? The ecosystem is the package group of components, okay, that are based on the Hadoop. So we call such a group of components which are based on the Hadoop is called Hadoop ecosystem. So we will see today what is a Hadoop ecosystem. Okay. Before we start to discuss about the Hadoop, the computer, most of the current computer has the CPU, right? And we have the memory, and we have hard disk drive. This is the component of the node or computer and server. But if this one node, one computer is not enough, big enough, or fast enough, not fast enough to process the data. The traditional way of addressing such a problem is we can have distributed system. So we have additional node, another node, another node, like the parallel system. This is called distributed system. So this is a typical way to address such a problem. However, if we are using such a CPU memory, this one, CPU memory, this one. So this is a distributed system. What is the problem? In this case, there's no way to communicate, so we need to connect through the network, right? Across the network. Still, problem. Consistency. We need to clearly divide the job by the node. Okay? Otherwise, if the data is changed in this node A, that cannot be applied to the B, C, D. If they are associated, there's no way. To address that problem, this is the shared nothing architecture. It's a parallel processing, but they do not share anything. If you can clearly divide your job by the node, you can use it. But not many applications are possible. So one of the solutions is using first the network, so mostly optic, fiber optics. So we can have the storage here. This is the typical configuration of the enterprise level system. We can share the storage. This is called storage area network, SAN architecture. Then we can every node can share the storage. So they can access easily the data modified by this one. But still problem during the processing. Update data will be applied to the memory. Such a update data will not be applied to this one. So some of the system connect the memory using the memory channel, but still very, very complicated. So still such a distributed system is not very reliable to process such a big data. So we had solution to process a big data, to manage the big data, but not very reliable. What about the programming level? Is there anyone who took the parallel programming course? We have the parallel programming course. In the parallel programming course, there are solutions. What can be the best solution to get the benefit of the parallel system? If we can divide the job of the application program by the node, then run. But as we discussed, it's not easy to clearly divide the job. Okay, so there is a software running on such a distributed system. For example, MPI. So when you submit the a.exe file, that calculate the prime number, for example. Okay, so this MPI, the library, check and process, divide the job into each node. It's a parallel processing, support the parallel processing. But not always the MPI provide linearly increase the performance. The more node you have, the better performance, but sometimes degrade. Because more complex, this one cannot handle all the situation. Okay, so that is the current technology. So we need to also, sometimes, what if this node is down? Then you need to sometimes run the entire application from the beginning. So it's not the fault tolerance system. So to address that problem, so first Google because Google has a lot of the data, huge amount of the data. So traditional, the database system, traditional file system, doesn't work very well. So they first investigate the file system. File system, which is a Google file system, is basically the distributed file system. What is a file system, by the way? File system.
File storage in a linear way. File stores in a linear.
So file storage, it's general file system. What kind of file system are you using on your computer? NTFS. Long time ago, FAT 1632. Or if we are using the Unix or the Linux, you use the UFS, okay? And ext 3, 4, 5, 6, no 5, 6, something like that. So there are a lot of file systems. File system is a software that manages files. Because the file is the only way to keep the information data. Okay, using the file, but variety of the file. Okay, but if that file system is located in one machine, you cannot get the full benefit of such a parallel machine. So file system itself should be distributed. So that is the distributed file system. The basic idea of the Google file system is distributed file system. Also, that file system running on existing file system. So if we are using NTFS, so on top of NTFS, so you have the NTFS. On top of NTFS, there is the Google file system. Okay. This is sometimes you can. Most of the time, you believe the file system will be installed on the low device, the hardware directory. Then, however, the distributed file system running on is based on the NTFS or ext 0, 2, 4, 5 existing file system. It can be viewed as the file from the NTFS or UFS. It's nothing special, but it has all the operation of file system. This is a Google file system, distributed file system. The reason is that when we have the multiple nodes, so this one will look like this. Okay? So this is the distributed file system. Then we can get the benefit of the distributed system. Okay. So not that simple. I will explain how it is organized. Then Google successfully implemented such a Google distributed file system and released the data structure algorithm of the GFS. That is your first reading assignment paper. Then people that was shocked at the time, 2002, 2003 at the time. So many company and the expertise and the programmer, they get together, they try to improve that the Google file system. That Google file system eventually going to NTFS, HDFS. It's a Hadoop distributed file system. It's a file system that you know, but it's a distributed file system running on the existing file system. Because of that, you don't have to reinstall the entire operating system when you install Hadoop. Instead, you can use your computer operating system as it is. Then, when you install the HDFS, the Hadoop system, it looks like just a file. It just looks like a file. Is there anyone who took the My Operating System class, the 2014? Yes. Do you remember the project?
No, it's not in. I've taken in the last semester.
Last semester, anyone? 2014? Or this semester? Anyone? So your second project, operating system second project is what? Portable file system. Actually, portable file system is much simplified. This file system. It's running on top of existing file system. Okay, that is one of the reasons I put that project. to understand this the distributed file system. Okay. Anyway, so that is the one thing. HDFS. Who made this one? Doug Cutting. Actually, he was the manager of the Google File System project, and he moved to the Yahoo. Then finally, found the Apache Foundation. Apache Foundation is as long as you agree something the open source product and something that the donation, then freely they provide, like the Apache server, web server. So there are many the Apache project. So it was one of them. Okay. Then some of the company and people, they love to use the Hadoop, but it's just open source. Because of that, they cannot use it. Then the Cutting and some other pioneer of the Hadoop, they make the company that is Cloudera. So that is the history, short history of the Cloudera. So this is one thing. File system plus, as I introduced before, in traditional way we can do the parallel programming, like they're using MPI and some other technique. But it's very, very hard and very, very complicated. So you cannot focus on only the algorithm. You need to take care of the parallel server and whether it's skewed or load balancing and everything. What about the toll? In case of fail, you need to restart. So programming level, parallel programming level. So Hadoop provide map reduce. It's kind of parallel programming framework. It's not a programming language. Anyway, MapReduce is based on developed by Java. So it's purely Java program. So which means it's not programming language. Somebody overlooked, is the MapReduce is a program language? No, it's the parallel programming framework. Using this, it's nothing but Java library that support all housekeeping work. So when you are doing the parallel programming, you need to consider load balancing or the synchronizing. You don't care. This MapReduce library, the parallel programming, the component, take care of everything except your own algorithm. For example, in the Google Fortran, what is the algorithm? Only count. That's it. It's a count. That is the algorithm. Okay? So in your MapReduce program, you can only focus on count. Number of what? Flu. Then all the other part, there is a MapReduce, the component will take care. Two parts. HDFS, the Hadoop distributed file system. This is the file system where you can store the big data, where you can manage the big data. That plus, in terms of programming, MapReduce. So if you are able to use such a file system, there's a command in the client Hadoop. For example, we will see later, you don't have to write. FS, the copy, move. So you have the command to upload the data to the HDFS, download the data, or merge the data, or something operation. That is HDFS. It looks like the command line interface. That is the reason in your operating system class you are doing shell programming in the first project. Then, in the mapping, after you upload the big data, like the Google, all the Google data, then I'd like to implement number of count of flu. Then it can be implemented by the MapReduce Java program. Then you can just, it's very simple. We will see example of that. We will learn the MapReduce programming next week and week after. So then you can, this MapReduce component will access all the distributed data. You don't care how it works. this MapReduce program will take care. Then the summarize that. Basically, as name implies, there are two components. One is mapping. Another one is reduce. Unfortunately, the MapReduce program, big data approach, deal with unstructured data or semi-structured data. It's not like the relational database model. In the relational database model, how can you access the data? Using primary key, for example. Then it's very quickly find the data. No, there is no key substitute. All the data, it will be considered as the only key value. You probably heard about KV, key value. Key does not mean the primary key. It's different from the primary key. Key is just whatever. It can be offset. It can be number. It can be the word. Okay? All the others are value. Then you need to narrow down. For example, the query, Google query, I don't know exactly how your query will be stored at the Google. So let's say there are something, the record, your query history. But it is true, whenever you type the submit the query, it will be stored at the Google server. Okay, so probably your time, the location, server, and something browser information, then query flew. Okay, sometimes it's not flu and high fever. Okay, so first step is you have many of the data. Key will be just a sequence number. It can be sequence number, also it can be, if you are using just one big data, this will be offset. It's a 0. The next line is 110. This one is 1,000. The number of character offset data. It can be whatever. Then value means this. The next step you will take out the flu. The next query may not have the flu, so you can ignore. So flu, for example, 0, flu. And there's no data, and next data, 1,000, 1,100, it has a flu. So you have such a number of flu. Then change it. This one has how many flu? Here. Key is a flu. Then value is how many? 1 flu. And flu, 1. Flu 1. So key does not mean the primary key. Key is nothing but representation of this value. Okay. Here, in this case, it can be converted like that. The flu is a key and value is 1. Flu is the key, value is 1. So this is called mapping. We'd like to map based on our request, the goal. Reduce is you have the millions of that one in terms of time even. So reduce combining based on the, so let's say sometimes flu, sometimes cough. So we collect the flu, cough, and other symptom word, okay, only. So sum up, during the reduce, we'd like to reduce the case. Based on what? Key. So flu, if you sum up all of this, it's a million. Cough, 500,000. Reduce the case. So this is a MapReduce. All MapReduce program based on the Hadoop following such a MapReduce architecture. We will see details later. You don't have to worry about right now. This is just overview of the HDFS and mapping. So remember, there are two main components in Hadoop system to manage the big data. One is distributed file system, Hadoop distributed file system, HDFS. Another one is programming level. So MapReduce programming, which is not the program. Don't say I learned the Hadoop program language. No, that doesn't make sense. I learned the MapReduce, the programming parallel programming framework. What can just this is the MapReduce. Okay, it's a parallel program. Okay, So hybrid component consists two parts, the HDFS map reduce. Plus we will see other component. This is called core component. Main component, two parts, HDFS and map reduce. All the others are ecosystem. Okay? We will see Hive, Pig, Uzi, and HBase, many others. Nowadays, the Spark is highlighted, right? Spark is very popular. I hopefully introduce the Spark. Oh, fortunately, this semester, one of the experts on the Spark big data system will visit the UB as an invited speaker, the Engineering 400. I strongly suggest you guys to attend that, the curriculum series. I will let you know when later. Okay. Plus two core component plus the other Hadoop ecosystem. This is overall Hadoop component. Okay. So if you install such a Hadoop component, that is called Hadoop cluster. Okay. So in your exercise lab, probably the 4th, 5th, so you will set up the Hadoop the cluster using the 3 or 4 computers. Okay. In the lab. So Hadoop file system is based on the Google the file system. So to understand the Google file system, best way is the reading assignment paper. Why don't you read the reading assignment and then try to understand. Then summarize with your own work what is the Google file system. The main purpose of such a reading assignment is whether or not it's not easy first time to understand such a technical paper. Try to understand. Sometimes if you do not understand, so you need to find the reference paper. Any technical paper, they don't explain details of everything. Instead, if some of the information are left out, so you can search the reference paper. Then that is the best way to understand the HDFS. Okay? As I said, it's based on top of existing systems, such as the EXT3, 4, 5, NTFS, any the file system. Okay? However, it is true, it's running on, it's based on the Unix or the Linux system first. They port such a system to the Windows system. So it's not a good idea to practice or install the Hadoop on the Windows machine first. Okay? It's the same idea, but in terms of performance, it's not so good. But in our case, it's just a practice. So we will use virtual machine, which is based on the CentOS, the Linux system. There are several important characteristics of the HDFS. First, what is the block-based approach in file system? Block. What is a block in operating system? Operating system block. When we are saying operating system, OS block, what does that mean? Block. Chunk of data. What kind of chunk? How can we use such a block?
Address.
It's a byte
Bytes of data.
byte of data. Yes, it's a byte of data. It's a basic unit of what?
Chunks.
Input and out. When you read the data, it's a block base. How many blocks you read? Even though I need only 1 byte of the data, but entire block will be returned to where? Operating system. Then operating system store that data in cache memory. Okay. Then will be reused. Why? There might be higher chance other byte of data in the same block will be recycled, reused. That makes sense. So that is a block. What is the typical size of the operating system block? Anyone?
4 KB.
4 KB is too big. 512 bytes in operating system. Why? Why this is so small? If too big, it will take a time to load, right, into the memory. Yes.
The small memory means it is easy to read.
Yeah, so there are trade-off, okay, pros and cons. But operating system has a smaller size, 512 byte. What about database block? Database block is much larger than that. 2K, 4K, 16K. Some of the data warehousing system has 1 megabyte. Why is it still big? Okay, so that is the block. What about HDFS, Hadoop? It's a 64 megabyte or 108 megabyte block size. So block itself is such a big. Why? Why is it so big? To processing the big data. We don't want, so this is I/O unit. We don't want any overhead. So if we use a small size, the block for the 1 petabyte, how many I/Os? So too many, right? So to reduce such overhead, we use as a default 128 megabyte. But sometimes we can use at minimum at least a 64 megabyte block size. That is one of the main characteristics of Hadoop file system, distributed file system. Another one, what if one of them is failed? We will lose all the data, right? We don't want. Even though it's a big data, we don't want to lose the data, right? So to address that problem, we have multiple copies of the data. So at least 3 copies of the data in the system, which means if we upload the Fluke Google data to the HDFS, automatically copied 1, 2, 3. Then later, when we read the data, are we going to use all of them? No. One of them will be used also. Each block will be used for one map reduce the task. So we will see details later. This one, read the data from one of the 3 blocks. However, in case this one is slow or failed or down server, something problem, Hadoop automatically restart the same job only for this job block restart. Okay, that is one of the characteristics of the Hadoop. So, which means we can support parallel. Also, we can support fault tolerance system. Even though one of them is failed, we have 2 more copies. Okay, so that